Week 3. NET-136 OS2. Any questions about grades or items? Talked a little bit about documentation and installs, the prep things you need to know before you install them. We did some basic command line interface, and we had a little bit of time working on GUI. We're having some problems with a couple machines, so we moved the due date for that back. Yesterday was the last day to drop classes. We talked about cyber defense coming up. We have a Newman project in which we have some PCs that need to be cleaned and upgraded. So that we're going to do that. Our IT group is going to work on that. And I talked a little bit about master transcripts, this concept of building a transcript of all the things you did versus having a grade. Competency-based type education, where we look at can you actually do the competencies, you know, the things you can actually do, and then when you apply for a job or apply to college, they look at your master transcript. So it's like people talk about keeping an electronic portfolio of all the things they have done, both in class and out of class, that make them a good prospect, let's say, for a job. Why I mention that, you should keep some type of place where you keep all of the work that you've done in school, so you could show somebody sometime. First thing we talked about was a little bit about hardware. And the reason we needed to do that is we're talking about an operating system communicating with the hardware. We talked about the kernel communicates with the hardware. Some of the things. We've got a processor. I just drew a box as an example. In the processor we have these high-speed staging areas called registers. We mentioned that just to talk a little bit about the history. We have 64-bit processors now. Previously they were 32-bit, 16-bit after that, 8-bit, and so forth. And now we have 64-bit path, and then we move things through a computing device. And we talked about memory, random access memory, and how then we had storage. We have programs and data in storage. We bring a program up into memory, like the operating system, the kernel, and then that program now can execute. We can take information lines from there to the processor. The registers, the processor can perform whatever operation on it, and then send the information back into memory. Maybe updated some data, did some calculations on some data. That's in memory. And then if you want to save it, you can save it back out to non-volatile storage. It keeps track of where things are there on a file allocation table. What keeps track of where this is in memory and where this is on the disk and which instructions get to process and which ones don't? It's the operating system, and internally it'd be that kernel initially communicates. How does the kernel get from storage into the operating system? Well, we have that boot process. we have some software, like in read-only memory or somewheres, and that software gets loaded initially, and then it goes out and finds the operating system out on storage and loads it. Used to be a two-stage operation, but now, and that was the initial BIOS. Now with our access to so much more storage in larger spaces, UEFI, Unified, I forget exactly what it is, UEFI, that is how most systems boot now, in which it can be just one stage. So that's the first thing we have to be able to understand. The operating system has to get loaded in the memory. We're going to talk about some more details on that next session. So, hardware, the kernel communicates with the hardware, and then a term we don't use a lot, but you need to understand now, you have some type of shell so that you can communicate with the operating system. So it's kind of like the application communicates with the operating system to communicate with the hardware, and the user communicates with the application. But in between, us as users can use the shell to communicate directly with the operating system. So we use a bash shell. There are other shells that are available, and it interprets, the shell interprets the commands we type to tell the operating system, the kernel, to do something. So we have an example. We downloaded Wireshark. We actually used the GUI to install Wireshark. Now, depending on your distribution of Linux, it might be a little different. Sudo authenticate us in order to be able to run this command with these parameters to add us as a user to a group. The group was Wireshark, and here is the user. So this is an example of a shell command that tells the kernel, the operating system, to do something. Append us to a group, and here we gave the group name, and here we gave which user. And this was, in this example, it was Wireshark, and then the one was in class. I was the user to add to the group. Alright. Remember, you want to keep working through the curriculum in the Cisco Networking Academy. It moves pretty fast. You know, we have the chapter, and then the exam, and coming up in chapter 4 you also have a lab, so those three things you have to be working through. And then we will work on a lot of the command line interface materials from here on in class. That's it.